Hey guys, welcome back to the class of pre-calculus. Today we're going to continue with chapter 3, roots of a polynomial, and we will introduce the topic of factorization. Okay, so here we have arrived to lecture 4, factorization, and the objectives of this lecture will be to introduce factorization of polynomials, to explain factorization methods, and to define the roots of a polynomial. Okay, so before starting with the method of factorization, we need to first define what factorization of a polynomial is. Factorization in math is basically take a number and break it down to smaller numbers that multiply each other. In this case, we're going to talk about polynomials. It means exactly the same. So when we have a polynomial and we factorize it, then we get smaller parts that multiply each other. For example, let's say that we have a polynomial ax plus b, and then we multiply it by cx, right? So remember, when we talk about multiplication of polynomials, it will be the same thing. Here we will have ax times cx plus bcx. Okay, so in factorization, it's basically that we have this part of the equation, and we are asked to find this part of the equation. So we are basically going backwards in the multiplication of polynomials. Also, factorization helps us find the zeros of a polynomial. What do I mean by zeros of a polynomial? Well, it means that you find the numbers that make that polynomial equals to 0. Usually, this is also reflected when you graph the polynomial. For example, let's say that we have a quadratic polynomial and the graph will look like this. When they say to find the zeros of the polynomial, they are referring to the 2 points where the graph touches the x-axis, because these 2 points are making the y values to be 0. Okay, so for example, for this quadratic function, these 2 points are the 0 points or the roots of the polynomial, because when you substitute these two values of x into the polynomial, the y value is going to give you 0. Okay, so that is basically what factorization of a polynomial is. It's just basically breaking apart a polynomial into simpler terms, and also it helps sometimes to find the zeros of the polynomial or the function. So in this lecture, we will see the most used or most common technique to factorize polynomial depending on what type of polynomial we're dealing with. The first one that we will introduce is called the greatest common factor, also known as GCF. Okay, so what this method says is that we need to see at the polynomial. Here we're going to start with this one. We need to look at it and find what is the common factor in each term, and then take it apart from it. How do we do this? Well, in this case, we can see that every single term is multiplied by x to a power. Okay, so but we can also find the common factor in the power. For example, let's say that we take x squared outside and then multiply by certain number, so that at the end we can get this polynomial back. The way we do it is term by term. Okay, so for example, we start with 6x to the 6th power. With what number do we have to multiply x squared to get 6 to the 6th power? We multiply by 6x to the 4th power. How do we know? because if we multiply 6x to the fourth power times x squared, then common bases stay the same and the power add each other. So we ended up with 6x, and then we add the power. We have 4 plus 2. This is equal to 6x to the 6. And that's exactly the number that we want to get. So if we multiply x squared times 6x to the fourth power, we end with 6x to the 6. And this process, we do it with each term in the polynomial. Now let's do the second term. Here we have minus 9x to the fourth power. So the question is, to what number do we have to multiply x squared to get minus 9x to the fourth power? Well, first of all, it has to be negative because x squared is positive. So negative, then x squared has the constant of 1, but we want 9 as a constant. So minus 9, x because is the common base. And when you have common bases, again, the power add each other. So to what number do we have to add 2 to get 4? Yes, 2. So we have minus 9x squared times x squared. It will be minus 9x to the fourth power. And now we do the third term. The third term is 3x squared. So to what number do we have to multiply x squared to get 3x squared? Well, we multiply it by 3, right? Because the x squared is already there. And here this x squared has a 1 as a constant. So 1 times 3 is 3x squared. Now we can see here we have two terms. And the question now is it possible to keep factorizing this term by another common factor? And the answer is yes, right? Because we have 6, 9, and 3. And all of them are divisible by 3. So we can take 3 as a common factor. So we could keep factorizing. We take 3 as a common factor, and we already have the x squared. So now, to what number do we have to multiply 3 to get 6? Now we are dealing only with the number because we already factorized the variable. So to the number that we have to multiply 3 to get 6 is obviously 2. So because 2 times 3 is 6. So we have 2, and we already had the x to the fourth power. Minus. Okay, to what number do we have to multiply 3 to get minus 9? Minus 3x squared, because we already had the x squared right here. And finally, to what number do we have to multiply 3 to get 3? Well, it's just 1. And that's it. So now the question is, can we further factorize this? Is there another common factor in this polynomial that we could take out as we did previously? The answer is no, right? Because we don't have a common factor either for 2 or for 3, and only these two terms have the x, not this one. So we cannot get x as a common factor either. Usually these two steps are done just at once, taking the 3x squared just one out, but I wanted to do it separately so you understand that you can take the common factor for the variable and also for the constant. Okay, so here this is our final factorization. Now let's do another example, a little bit more complicated. Okay, here we have 15xy cubed times x to the third power minus 2 minus 4x squared times x cubed minus 2. Okay, so there are many common factors here. Remember that you can have the common factor for the variables and for the constant. In the variables, remember that can be x, y, w, u, whatever letter that changes depending on the value that you assign to it. So in this case, we evaluate term by term. How do we know in so many numbers what are the terms? Well, we know that terms are separated by addition or subtraction. Okay, I understand that here there are another minus sign, but they are in parentheses, which means that all this entire parenthesis is multiplying this term. So making this entire thing a term and this entire thing another term. Okay, so let's start identifying the common factor. Let's start with the constant. We have 15 and 4. Are they common? Do they have a common factor between them? Can we find a number that can be multiplied by something else that gives us these results? No, right? So the constant cannot be factorized or cannot get the common factor. Let's go with x. This term has an x, this term has an x. So x can be factorized. So we write x outside. Now let's go with y. This term has a y, this term doesn't have a y, so y cannot be factorized. Okay, so now let's go to the parentheses. Parentheses should be taken entirely. You cannot take x cubed separate from minus 2. You have to take the entire x cubed minus 2. Okay, so in this term we have an x cubed minus 2, and in this term we also have an x cubed minus 2. So what do we do in this case? We write it down outside the parentheses. So we have parentheses x cubed minus 2. And these two are our common factor, x that multiply x cubed minus 2. Now to what number we multiply these two? Well, we multiply by the numbers that couldn't be factorized or didn't have a common factor, which were 15y cubed. Remember that we said that 15 cannot be taken as a common factor because it doesn't have anything with 4. So 15y cubed. And for the other term, we have minus 4x, right? Yx, because here we have x squared and here only we have x. So it has to be x times x, we get x squared. And that is how we factorize this polynomial using the greatest common factor. So let's recap. We start analyzing the constant, right? Remember that the constant is the number, to see if they can be divisible by each other or if they have a common factor. Then we go to the first variable. In this case, it was x, and we were able to take x as a common factor because this term has an x and this term also has an x. The next step, we evaluate the second variable. In this case, the second variable for us was y, right? We have one variable here, which is x, and the second variable here, that is y. Okay, so then we ask, okay, this term has an y. Does this term has a y? It doesn't have a y, right? So y cannot be taken out as a common factor. And the last step, we take the parentheses, right? Entirely. We cannot separate what's inside the parentheses. The parentheses behave as a one variable. And it happened to be common in both terms. That's why we took it outside and multiply it. Finally, we add the terms that were not that did not have a common factor. So terms without common factor. And that is how we achieve the factorization of this polynomial.